Now that we've talked about the mean and the standard deviation, there's a great tool that we can use as a result. We can now combine these two things and use it to get a good idea of the probability of observations that lie within one or two standard deviations from the mean. And the easiest way to show you this is to draw a graph. I'll make it kind of big here. And I'll do my best to draw this accurately. What I'm going to draw is a bell-shaped curve. And it will look something like this. This is a bell-shaped curve. And looking at this bell-shaped curve, we can tell that our mean is right in the middle. We'll call that mu. All right. So what the standard deviation allows us to do is it allows us to determine the dispersion of this graph. How much data lies here, or lies here, or lies here. Or it also can tell us how much should lie here, or any version of this. So what we do is we can take our mean and we can add one standard deviation to it. So now this line here is mu plus 1 sigma. Corresponding, we can subtract 1 sigma also. So here this would be mu minus 1 sigma. And we can keep going on and on. We can add 2, add 3. Here we can subtract 2, subtract 3. We can keep going to 4. We typically stop at 5 because the observations will typically lie between plus and minus 3 standard deviations. If anything lies outside of plus or minus 3 standard deviations, it's considered very rare. So I'm going to come in here and just finish labeling this. This is mu plus 2 sigma, and this is mu plus 3 sigma. And I'm going to do the same thing over here. This is mu minus 2 sigma, and here is minus 3. So you'll start hearing me say some shorthand. If I say 1 standard deviation away from the mean, that's referring to this point right here. If I'm saying it's when I say 1 standard deviation from the mean, it could be either one of these. If I say something's 2 standard deviations from the mean, it could mean out here. So just getting used to the terminology is real important. Something else special comes from this. We know, and this will be something talked about later, by the law of large numbers, that the bigger your sample or the bigger your population, the more and more true it becomes a bell curve. All your populations will eventually look like this, or all your observations. So what we can do is we can say anything that lies between 1 standard deviation, so either way. Observations that lie between plus or minus 1 standard deviation, that we can say that 68% of the observations lie within that range, which is a very handy tool to have. And we can extend that further. We can go out to plus or minus 2 standard deviations. And we can say 95% of all observations lie within plus or minus 2 standard deviations. And going out to 3 standard deviations, we can say that 99.7% of all observations will lie between plus or minus 3 standard deviations. So only 0.3% will lie outside of this range. So that's why we only focus on these. And just to put some more words on the paper and kind of help you understand, this is what the empirical rule says. Approximately, and it's approximate, but it's a good approximation, especially early in experiments. Approximately 68% will lie between mu minus 1 sigma and mu plus 2 sigma. Or I could have said plus or minus 1 standard deviation, plus or minus 1 sigma. I could have said that also, which if I would have wrote it, it would have been written like this, plus or minus 1 standard deviation. This means the same thing as what I just wrote right here. So just get familiar with that terminology. Continuing this trend, we can say approximately 95% will lie between plus or minus 2 standard deviations. So there I wrote it differently. I can write it either way. And then lastly, I'm going to just draw a line here, means approximately, so I don't have to write that word again. 99.7% will lie between plus or minus 3 standard deviations. So that's the empirical rule. Now what we want to do is apply this to an example. A simple example just to kind of get our feet wet and see what this is all about. So, and keep your empirical rule handy. You'll need it just off to the side or however you're doing it. Example 1. So the average number of popcorn kernels in a large bag, in a large movie bag, is 357 with standard deviation (13 kernels). Answer the following. And we'll do part A first here. Let's say what proportion of large popcorn bags will contain, that should be will contain between 344 and 370 kernels? Question mark. What proportion of large popcorn bags will contain between 344 and 370 kernels? So the easiest thing to do here is to draw out the empirical rule, an actual graph. So let's do that. So I'll draw one real quick here, just like this. And I know my mean is here, and it told me my mean in the problem was 357. And I know my standard deviation is 13. So if I go plus 1 standard deviation, that's here. And I should write mu equals 357 right here. And then here I know this was, so let's just write it out so we don't have to do it in our head. Mu plus 1 sigma. And then here is mu minus 1 sigma, mu plus 2 sigma, mu plus 3 sigma. And I'll do the other side too, subtracting. So there's our empirical rule. So mu is 357, to find plus 1 standard deviation away, that means I take the mean, mu, and I add 1 standard deviation. So I said the mean was 357 plus 1 standard deviation, which is 13. So plus 13. That means this is 370 here. Now let's find minus 1 sigma. This means it's mu, which is 357, minus 1 standard deviation, which is 13. That equals 344. And then let's finish out. So here I just added 1 standard deviation. To get to 2 sigma, I add another standard deviation. So I add 13 to this, which is 383. Then I add another 13, which is 396. And then we go backwards. Subtract 13 from this one, and you get 331. And then go backwards one more. Here you get 328. Oh, 18, sorry. All right, so now we have our values here. And let's go back to part A and see what it's asking us. What proportion of large popcorn bags will contain between 344 and 370 kernels? Well, here I can see it's 344, and here is 370. Those are exactly 1 standard deviation away from the mean, plus or minus 1 standard deviation. So, and based on the rules we just talked about, anything between 1 standard deviation, anything 1 standard deviation from the mean is 68%. So this is 68%. And we can tell just that fast. All right, let's go to part B. I'm not going to do as much writing this time. I'm just going to tell you, find the probability that it's between, the proportion that's between these kernels. Let's say 331 and 383. Please pause the video and work this one yourself. That will be the most helpful thing for you to get in and actually learn how to do this yourself. So please do that and then come back and see what I'm doing here. So looking back at my graph, I see 331 is at minus 2 standard deviations and 383 is at plus 2 standard deviations. And based on our rules, I know anything that lies between here is 95%. All right. So that means this is 95%. Let's do one more. C, 318 and 396. This again goes back to our rules that we wrote on the first graph. We see that we're at minus 318 is at minus 3 standard deviations and 396 is at plus 3. So now I know that anything that lies in that range is 99.7%. All right, let's try a little bit different one here. Let's try part D, 331 and 370. So looking at our, and I encourage you to pause and try this one. This will be a great opportunity for you to dig into this a little bit more and give it a try and come back and see me whenever you're done. So let's look at our points here. 331 is minus 2 standard deviations and 370 is plus 1. So we're no longer working within these pretty boundaries that we set. The 68, 95, 99, 7 rule. So now we have to dig in a little deeper and start splitting things up. So let's look at plus and minus 1 standard deviation. So 1 standard deviation away from the mean is this portion here. Since I know this graph is bell-shaped, it's symmetric, then I know that these two halves, these two portions are split in half directly. So all I do is take 68%, divide by 2, and that means 34% lies here, and 34% lies here. And then I can keep going further and further out. So I know 95% lies within 2 standard deviations. So this one's a little bit trickier. So you only want to find this portion here and this portion here. So to find that, you take 95% and subtract it from 68. So what you get is 95 minus 68. That gets you 27. So that means that 27% lies in these two total. So now you would want to, that implies that 27 divided by 2, which is 13.5, lies in the middle here. And so that's a percentage. So to rewrite that, that means 13.5% lies here, and 13.5% lies here. All right, so now let's go back and see if we can figure this out. Part D said 331 and 370. So here's 331 and here's 370. So it lies between these two pins here. So all I have to do is add these percentages together. 34 plus 34 is 68, and then plus this 13.5%. And so that's all you have to do here. So 68 plus 13.5 is 81.5%. And that's it for this one.